Welcome, everyone. Azure Cosmos DB Live TV. I'm your host, Mark Brown. Welcome back again for joining us this week. Episode 15. This week, we're going to take a kind of a behind-the-scenes look into something new we've built. We just announced actually recently at Build as well. I'd like to welcome Mei-Chin to the show. Hi, how are you?
Hi, Mark. How are you? I'm good.
I'm good. Yeah. Good to see you. You want to talk a little bit about yourself? Just introduce yourself to the viewers.
Sure. My name is Mei-Chin. I am a group engineer manager at Cosmos DB. My team owns Cosmos DB's front-end gateway and OSS API, such as Mongo, Cassandra, and Graph. And before, I have been in Cosmos DB for about 16 months now. Yes, I'm counting the month. Before that, I was a group engineer manager at developer division at Microsoft as well. I own .NET Runtime, and I also own Rosalind, which is more well known as a C# compiler and VB compiler code base.
Wow, that's quite remarkable. That's some cool stuff you're working on, and obviously you've kept up the cool factor by joining our team. Because there's nothing cooler than distributed NoSQL databases, at least in my opinion. That's why I love what I do. So today you're going to talk about this new kind of feature behind the scenes with this dedicated gateway we've built. So, and just to kind of context set for folks, Cosmos is a multi-tenant service, right? So we have, and this is actually your team as well, our kind of front-end gateway where requests come in and are routed to the back-end partitions, for physical partitions where your data is stored. But all that is all meant multi-tenant, and this is something different, something new, correct?
That's exactly right.
Yeah, so let's talk about, I guess, or I'll let you talk about dedicated gateway and kind of give us kind of this behind-the-scenes look.
Absolutely, yeah. Well, every single project has a code name. And I would like to share our code name. Our code name is actually called SQLX. Of course, you did not hear it from any MSDN doc or anywhere, but that is what we refer to ourselves.
Why did we call it SQLX?
I think X sounds really cool.
Yeah.
And SQL is because the first API that we offer in for this particular dedicated gateway services is in SQL API. And X is kind of cool, and X also is kind of like sounds like caching maybe.
Yeah. It's a code name, so it can be whatever you want, I guess, right? So
absolutely. Absolutely. So I'm going to advance my slide.
Yep.
Can you see it?
Yeah.
Okay. So first of all, I kind of want to go over today's agenda. Since this is a behind-the-scenes talk, I would like to start with how do we form the idea? How do we get the idea, right? And then when you have an idea, we are in business. We are here to serve customers. We certainly want to make sure our idea is something that customer wants. So cover some of the initial customer scenario studies and how we build a POC. And with a POC, you go back to customers again, trying to validate what we built. It is really bringing the value for the customers. And I want to talk about the challenge that we have for wrapping up for the public preview. And of course, a little bit of forward looking. This is the first step in this particular offering, and certainly there are many more potential that we unlocked. I would like to cover a little bit of that.
Okay.
So with that, I think, Mark, you did a great job at the beginning talking about what Cosmos DB is, right? Cosmos DB is a service that provides high throughput, low latency, and high availability for NoSQL data to customers. And this customer request come in volume, and you'll receive by the gateway. And gateway does API specific transformation and design planning and send it to the backend where the store is at. And waiting for the result coming from various different places, doing the transformation, aggregation, and bring the result back to the customer. The promise is certainly low latency. We have to be fast. Had to be high throughput because there will be volume. I mean, Amazon Prime Day, certainly Amazon is not hosted by Cosmos DB, but we have customers similar to that, right? And also the high availability. we host business critical services.
Yep.
It cannot be done. That is actually no.
Yep.
And so if you look at this particular diagram and thinking about what the shared gateway has to do, you have multiple tenants coming in. You have to be fair. You cannot prefer one customer versus the other one. You have to be secure. Customer data is very important to make sure that it is, secure is number one, right? And so with this, there's a certain overhead got put in there to management the request to ensure that those criteria is met. It's also really important to notice that because we want to be secure, this shared gateway does not hold any state between requests because you do not want to leak any data. And so the gateway here, we ensure each of the customer has some limited resource and make sure that we do some sort of resource government, that you can take out too much resource, therefore you impact the others. So what is our observation on shared gateway? We did a good job. Nobody complains about Cosmos DB's performance. I mean, we certainly fit into our SLA.
Well, if they do complain, it's usually their fault though, right?
I don't think I'm supposed to agree with you. Not on TV, customer is always right.
Customer is always right. Yes, I misspoke. Sorry.
Absolutely. So reflect back to what we talked about in the previous slide. We ensure each customer only has limited resource. That resource translates to memory and CPU. So that means if your query requires certain compute power in memory and CPU, they may not be able to be served. Queries such like aggregation, that you need to do a lot of computation, or like group by, or maybe like order by, that you get result back, you need to do sort. And certainly we support that in Mongo, but there are much more complex query that we just cannot do it because otherwise you may impact the other gateway, other tenants. The second thing is actually we cannot have a state between requests that we cached. There are certain query, such as distributed query, actually needs a previous state of the query in order to serve the next one. That's why we cannot serve those. Also, materialized view is another example where you map the view in and you actually want to serve several requests. And those are kind of limitation. That doesn't mean gateway is not good. It is good. It's built for what it is trying to serve, right? And also remember we mentioned about because we need to be fair to everyone. That means there's resource government got put in and there's a certain slight overhead that was imposed to ensure the fairness. Customer may encounter higher latency due to other traffic spike. We are still within the SLA, but the variance could be slightly bigger. And those optimizations are really hard for us to do without trade-off some of the promise that we have.
So I had some questions. So I heard in the past there was like customers would say they hit some 40 meg limit. Is that the resource governance in the gateway? That's
document size?
I think it was like the size of the memory pay or the return payload was hit like a 40 meg size. Is that the resource governance in the gateway that's enforcing?
It is possible. It is possible. Yeah.
And then how about continuation token? So you were saying there's no way to store state on the gateway, but the continuation token is state though, isn't it?
Continuation token was sent back to the client as well, right? They pass back.
I see. It's just not persisted or stored in the gateway.
It's not persisted or stored in the gateway.
Got it. So then that makes sense, right? Because then the customer is going to send that back and say, I need the next whatever.
Yeah, so you can see the customer did kind of implicitly managing certain state on their side as well.
Yeah.
It's a kind of a several requests to form.
To get all to drain their query, basically.
Exactly.
Yeah. Okay.
Should I move to next slide?
Yeah. Go ahead. Sorry. I'm just going to ask you.
No.
I often use these podcasts to ask random questions.
I love it. And if I cannot answer, I will delegate.
Okay. That's fine.
Yeah. So that was the observation on the shared gateway characteristic. And let's go back from a different angle, looking at what our observation on customer workloads or real life scenario. Cosmos DB is like what planet scale data we can scale out so well. Now the question is, are all data equal, important to customer at a certain period of time? And so you should know. Well, our observation is at a certain narrow period of time window, only small subset of data are important to customers. And those data are repetitively fetched and used, or sometimes the query that coming in from customers are similar, or sometimes it could be repeated. And it just depends on the workload. And so our observation is that we actually have a fair amount of customers that they put a cache mechanism in front of Cosmos DB to reduce the cost for the redundant and repeated requests that's sent to Cosmos DB, and just to fetch the same result.
Yeah.
So with this kind of observation from the shared gateway and observation from the customer data, here comes some sort of idea that, hey, what if we can provide a different offering? That is where the customer can provision their own gateway as their dedicated resource and use that resource to do more work for them. And that work could come to like either customization or optimization that works for their workload. And for us, if a gateway is dedicated, we can also further optimize some of the overhead that we have incurred when we are doing in the shared gateway. Remember, we talked about the management, resource management, and to be fair, to be secure, we cannot cache data. And some of those can really get optimized and get bring in shared gateway, in dedicated gateway, and bring that value to the customer. Make sense?
Yeah, that's awesome. So I could see this being kind of a huge benefit for exactly that scenario you were showing a couple of slides ago, where you've got these noisy neighbor problems, or you're running like high volume of cross-partition queries, and you're trying to do, you're fetching large amounts of data. And what's interesting is that, with the scale-out database, the bigger your data, the more expensive the cross-partition queries get, because there's more physical partitions you have to go and actually query there, and you need a place to be able to kind of aggregate that data, I guess, if you will. And in a multi-tenant service, that you're just going to get a small sliver of VMs, CPU, and memory to do that work. So how do you do that? Because I could see in a lot of sense what you were saying is, like, if you're going to run high volumes of these queries, it doesn't make sense to force every client to bring it all down.
Of course not. So let's move on to my next slide. This slide actually illustrates the new offering coming in as dedicated gateway and how the Cosmos DB is service. Right now, customer has choice between a free shared gateway or use a dedicated gateway to cache some of the result and do more computations on them. And this way, you got a resource that can give you an isolation and only to you, and see what you need on your workload and tune the compute to do just that for you, and do not have to worry about a generic and shared gateway. With that, I would like to kind of jump into the behind the scene.
Yeah.
So now we kind of got to see some more work that value that can bring into customer by building dedicated gateway. And we also see the value that we may be able to bring to customer as a cache. And now the question is, what does customer want? So we have a bunch of hypotheses that say, if we can let customer provision compute resource, and if we can put a cache in there, and if customer pay for this dedicated resource and reduce the resource charge from the backend, what is the goal and value plot? There's certainly many value plot. Initially, you can think about with a cache, you can talk about performance, right? If you don't hit the backend, like if you say cross-partition query, if you just hit it and get it back, it's not fast, awesome, right? you can also see the value of the cost reduction.
Yep.
But then which one is actually what customer wants, or more of a higher pain point? So we talked to about a dozen of customers, and it was interesting. Before we talked to the customer, we thought performance is what people is putting a cache in front of Cosmos DB. And as it turned out, a lot of our customers are trying to reduce the cost. Because if you go back to the earlier, we talked about not all data are equal. And the fact that without a cache, the repeated request, the repeated data got fetched so many times, that cost is actually redundant and unnecessary. And so that is kind of good insight from the customer for us. That knows that before we go to production, we should need to make sure that our value plot is clear, right?
What's those customers you talk to? What percentage of them were doing like high concurrency cross-partition queries? Was it all of them, or most of them, or?
Actually, various different kind of workload. We do not want. We want to make sure we are not skewing one or the other, right? So we talk to. We have customers that are actually more of a single partition, but the document itself is so big, could be big, then it become expensive.
Oh.
Because 1 IU is what 1K document reads.
Yeah, 1K document or less. That's right.
Yeah. So what if you have a kind of different sizes of document, and your document tend to be on the bigger side? Even just read itself can be expensive.
The RU charge can kind of grow logarithmically, I think, when you get into these really large document sizes. I've seen kind of a step table of.
Yeah, it's not linear. Initially, I thought it was linear, and I was thinking, oh my gosh, 1K document is 1 IU. If I have 1 megabyte document, it's 1,000 IU.
Yeah,
it's not. It is not. It's like 156 or something, but still, it is not cheap.
At high volume, that's expensive just to pull a single document out. So,
absolutely. Yeah. So I don't know if that kind of answer your question. So we try not to be biased, because you want to do enough sampling and to make sure that what we bring is actually the main line, right? And then we would cover other scenarios, but.
Yeah, makes sense.
So with that, we talk about thinking about having a dedicated gateway, right? It doesn't come free. What if you think about what kind of engineering effort had to go back in to support that compute resources dedicated? There are quite a few things that went in there. First one, you need to be able to subdivide the machine, because not everybody wants a whole machine as a gateway. That may be too expensive. And that is why we build a shared gateway, right? Because you want to make sure that machine powers are being used. And so we need to work on the ability to subdivide a machine without the overhead of the full VM, because you can easily think about, why don't you just provision smaller VM, because VM has overhead. And so we went through some sort of process level. We do process isolation, and we ensure that each process only have certain numbers of core, certain sets of memory that it can use. We also need to enable customer talk to their machine only, their provisioned process, right? So there's another feature got built in here that we actually did not announce it because it's fundamental there. It's actually a customer load balancer that you can make sure at one endpoint only come in and talking to a small subset of resource. And then we decide the SKU of dedicated gateway. This is the initial set that we think that could be useful for customer. D2 stand for you have 2 core, and then you have 8 gigabytes of memory. And you can see 2, 4, 8, 16, 32. I think there's any surprise. And then we map to a cost, right? Mm-hmm. And then so this was initial thinking, and
Very cool. Are the gateway instances, are these basically containers?
No,
they're not.
It could be container. It could be process. Container has a little bit more overhead than process.
Yeah.
So in SQL X, dedicated gateway for SQL API, it is all our code. our code we can audit, it can be secure. So they can be run in process lightweight. And if you are hosting that environment, the code is usually could be found elsewhere, then you need to, even with the subpartition of the machine power, you also need to make sure it's secure. And then that way we run an in-container environment. And then that will have a little bit more overhead. But process of container really should be transparent to customer. And you should just thinking about the number of cores, number of memory that you're getting, and things that happen in that space.
Okay.
So we have a dedicated gateway, and we talk about cache, right? Because we want to, we now we have CPU, we have memory, we want to bring more value into customer. You do not want to just process requests. How can we do customization, optimization here? So cache is the first service that we laid up. Our initial thinking was, well, what can you cache? Documents, because if you read hot data, makes sense to cache it, right? And our thinking is query, because as you mentioned earlier, many queries could be cross-partition, and cross-partition could be expensive. Can we cache a result for it and reduce the cost to the backend, paying more in the front, and get a more stable guarantee of the services of what SLA you want. So this to cache is actually read true. All the API, SQL API supported in here. If it's not read or write, query, it still go true. It is fine. You do not do anything special. So it's just like a SQL API.
Yeah.
And cache is really integrated. That's why it's called integrated. You do not need to do any more magic, right? And the write is actually write to cache. And we build in some heuristic about cache staleness, like for how long an item considered stale. And then we were trying to make sure read back on the backend if requests come in to do the best service for customers. And cache can be full, depends on how you use the data. And we're talking about is a sliding window. And a certain time when cache is full, then our eviction policies on the cache to empty more space for the other items to come in is LRU, the least recent used, will be evicted. And our read is the eventual consistency. And so with that, we kind of happy with the skeleton of story that we are thinking and kind of makes sense. And then of course, metrics. It is very critical for customers as well. There's a set of metrics that was actually corresponding to dedicated gateway to make sure that the resource that you have is healthy, like your CPU usage, memory usage, and etc. And then there's also something related to cache health to figure out like your hit rate or expiration count. And that kind of give you a clue to know if you're provisioned in the right SKU. For example, if your usage is really low, CPU or memory usage is really low, and maybe you don't need such a big SKU, right? But if your hit rate or if your expiration count is super high and your CPU is getting like a more in the throttle space, that we usually like to see 60, 70% or 80 to be healthy. But once above 80, you will worry about it because the workload is never linear. Sometimes you spike and you do need to leave room for yourself. Now, so that is what this is.
That's so it makes sense. I mean, you'd want to, and I'm glad that we built these monitoring metrics around it, because as you're obviously going to test this out, you would want to see like what's the ideal size for this. And I guess there's also a measuring is and I'm guessing this is always going to be true, but is the cost of the gateway offset the RU charges I'm experiencing for these high concurrency reads, whether it's point reads or queries in there as well. So that's cool that we expose all that stuff. I think this is something that I would want to look at, and I'm sure customers will want to set up Azure Monitor on these just to be able to keep an eye on it when they're load testing. Absolutely.
Absolutely.
Very cool.
So here we are. we have some skeleton story. We have some product. We are not shipped yet. So we went back to customer to validate some of our assumptions and also trying to make sure the customer experience is good. We boarded about 10 different customers to our test environment and like Canary and whatever. Mm-hmm. And they actually do use it, and then a couple months and give us that feedback. There are some feedback that actually really help shape the product. One feedback was coming back was, all workloads are unique. Not all of them are the equally distribution between read and query. Some workload is actually read heavy, and some workload is actually query heavy. The fact that we have a limited resource, remember dedicated gateway, and you provision D2, D4, it mapped to a certain number of gigabyte. And we split that into two cache. One is the item cache, one is query cache. If my workload is read heavy, then what would I want to put the equal weight on the query cache, right? And so that feedback and insight is super critical. And so we came back. We actually merged two cache into one. So you can leverage the memory usage better, and give user a little bit more flexibility. And even if your workload was spike on read and then spike on query and then spike on read or spike on query, then that memory pattern can also be accommodated without compromising. Mm-hmm. And so super cool. And second thing that we learned from customer that also helped shape the product was we have this cache stillness that we talk about, and default is 5 minutes. It was interesting enough that customer told us some workload may send in different query, but different query has different sensitivity to how still data can be. And that is actually interesting insight for us, right? And so we took that feedback and we implemented another flag that you can pass in with your request. That's called max cache stillness. So that kind of give you an escape valve out from the global policy. And of course, it sounds so easy, right? To implement a flag, what's a big deal? Actually, it's a big deal everywhere. If you assume everything's a 5, everywhere is going to building assumptions 5. To bring in a more granular flag, that means you had to pipe through the API, the request all the way down. Wow. And so these two feedback are super useful for us to get.
It makes total sense, actually, now that as you talk about this, that customers would want variable staleness depending on the type of data. I could totally see like a high volume of like if you're an e-commerce scenario, like high volume of reads for like products in a product category or something like that, not going to change hardly ever, right? But other queries in different scenarios, I can't think of any right now, but would change quite frequently, and so you would want different numbers on when you expire that data in there. That's really cool. One question I had is, so I'm guessing this is just basically a key value store, and you have these two different types of request or data. You've got the point reads, which is a partition key and an ID, and then you have the query itself. So the key values in this key value store, I'm guessing, is basically the two values for the point read and then the query text or something in there.
You're absolutely right. Yeah. Okay. And so for the item cache is document ID as a key, and then for the query cache, it's actually just one cache. Yeah. But if it's a query coming in, it's actually the full text for the query plus continuation token. That would be.
Okay, right. And then of course the staleness metric as well.
Absolutely.
Can't forget that one.
Yeah, don't forget about the timestamps.
Right.
It might be a minor detail.
Right.
Yep. Should I advance to the next slide?
Yeah, sure.
So with that modification and we refine the product, we think we are ready for public preview. But now, to go to public preview, there are certain gates that you need to pass, right? We host very high bar to our engineering system. We say this feature is to enable customer to reduce cost. However, that doesn't mean you can regress latency or throughput. Ideally, faster, more is better. But the number one bar, the entry bar, is no regression, on par, right, in parity. And so we kind of put a lot of things, effort in. And one thing also to remember is we talk about D2, D4, D8, D16, D32. But if you look at our public preview, what we expose is D4, D8, D16. What happened to D2 and D32? Because user may not see it, every SKU that would go out is another performance tuning. Because when you have a different set of cores, different sets of memories, the performance pattern will be different. I actually would like to point out that I would like to see myself being a platform layer. That means I'm very sensitive to operating system.
Yeah.
And I'm very sensitive to what underneath me as a runtime. Funny enough, it's a .NET runtime. The gateway code is in C#, my old life. You're laughing, yes. And I got GC, determinism. How do we ensure that things was in the right place, right?
Yeah.
So it just took a engineering team, a couple months to even just root cause how come our performance is not stable. And we found that in order to get the stable performance behavior from C#, the job object itself that was specified to the process, we also have to do core affinity. Because otherwise, when process is being run between different sets of cores, even though it's just 4 cores, but arbitrary 4 core here and there, it's not exactly the same. There will be some overhead that will happen in the meantime. So it's certainly a last minute push, and to just nail it down to know that the solution is actually to get to that core affinity. I would say it's not trivial. It was a bit scary at a point, I guess. Oh,
that's fascinating. So you were experiencing high and I guess for quite a while unexplained variation in your latencies.
Yep.
And then the solution turned out to be using core affinity on the garbage collector?
On the .NET process.
On the .NET process, right?
Yes.
And because of issues with garbage collection, is what you're saying?
Garbage collection and also the operating system, right? You want to make sure that the operating system does not come in to schedule your process to run on different sets of core. Because if you already run on a set of core, and if the operating system come in, decide later on to swap you with somebody else or move you around, that actually do incur overhead.
I see. So you don't want to be, I guess it's preemption.
Nope. In a way, yes.
Yeah.
Yes. And that just shows how sensitive we are to performance, right? And it's pretty amazing.
I mean, are you measuring latency at the microsecond level? Is that fundamentally it, right? Because it matters, right, at these volumes. That's great. Sure, I'm glad you joined us from the .NET Runtime team. I think that you were the perfect person to help us with that issue, or at least to figure out where do I go, I guess, right?
I'm not sure if I'm the one to come with the answer, but I'm really grateful that we have a team that's such a strong team. I think at the end of this talk, you will see some of the kudos. Many of them are low-level system programmers, and this is really a joint effort and a lot of engineering going in. And we build dedicated gateway, and we talk about like cache. We talk about customer load balancer. It's about 2 years of journey.
Wow. Yes. I don't think people realize just how much work goes into building a service like this. Or this is just a fraction of, Cosmos. It's and a new piece of it, but 2 years of work.
It's 2 years of work. Yeah.
That's just, that's fascinating. And
it is fascinating. I am a performance lady. I like to make things fast. I'm a low-level system programmer. Okay, I'm manager now, but that's the area that fascinated me. And so I think this is just a perfect place for me. And
Right, because it's the ultimate arbiter of success is the latency. Obviously, you're building a cache, right? So
absolutely.
yeah, it makes total sense. So
Yeah, we shipped. And you're laughing at this slide has nothing. This need a lot of more emotion coming out from it because
yeah,
I'm just thinking about the effort that went in and how many people are in it, right? So what's next? Well, we talk about performance and throughput tuning. We are in a good state. We can be better.
you're gonna go more.
We want to bring more value to customers, right? And remember, we talked about D4 to D16 was public preview. We want to scale up to D32 for bigger workload. And we want to also scale down to D2. D2 is actually interesting for a developer experience of somebody who wants to just try it. It's a much cheaper environment.
Yep.
We talk about the D2 to D32, scale down, scale up. There's also scale out. Today you can actually provision multiple instances, but we do not have sharding. So all the instances are equal. You're just multiplexing requests between instances. And if you have sharding, that means that you can, we cannot design it yet. So, but to leak out a little teeny tiny of an idea that we will allow people to say that, either provide some sort of partition key or hint key, and we can do hash and then decide where that request should go. And if you think about it, if you have 1,000 different requests, and if I can subdivide it into 500, and each of them hit to a different cache, the cache locality will be even better.
Are you going to do, so if you do sharding, is it going to be a hash or a range?
We don't know yet. That's why I cannot commit. Still in the design phase. That means customer feedback again, right?
Yep. Wow. So, and if you're going to have a scale out, so do you need a gateway of gateways to route request, or how does that work?
Top.
Okay.
Maybe we talk about custom load balancers sitting in front of that dedicated resource.
Yeah.
So there'll be some bunch of not really dark magic. It's a hard problem to solve.
Yeah.
I'm sure that we had just the right set of talent to solve it. So that certainly is one of the hard problem that we were thinking about maybe tackle it, and certainly customer feedback again there is super critical. And today our dedicated gateway called SQLX is only SQL API. It actually does not link to limited to SQL API. We see the same customer patterns in other APIs such as Mongo, Cassandra, right? Even Graph can benefit from it.
Yep.
And even in SQL API, there are some of the features that we talk about that was not able to supply in the shared gateway. Aggregation, in-memory aggregation, distributed query, or cross-document join, and many more, and can like that. So we have many options to build. Now the problem is that we unlock that potential, and there are so many choices, and we only have fixed amount of team size, what to prioritize. Yeah,
it's amazing what, and I go back to my, like the beginning of the show, right? Like we're a multi-tenant service that, and once you're multi-tenant, and also given that we optimize around things like latency because we have SLAs on that sort of thing, it forces you in terms of what you can and cannot do, right? But now with a dedicated tenant, you can open up the possibilities for these things you're talking about, like these in-memory aggregations and distributed queries and cross-document joins and all these other things, because you don't have to deal with the resource governance. It's basically whatever you provision, you can use. It's all yours, and so you can do these types of things. So fascinating. I love this stuff. So
yeah, I'm very excited, and we just open the door and stay tuned to see what other value that we bring into this place, right?
Yeah.
And
I just want to share a comment from one of our viewers. You are an inspiration, madam, and I would say I agree with that 100%.
Oh, thank you so much. I was worried that I might take the show.
No, I tank the show every week. It's okay. No worries there.
Okay.
So some docs here. So yeah, folks, if you want to take a screen cap of this or write down as quickly as possible. Here's some good documentation links and resources and stuff.
Yeah, we will. I want to give kudos to our PM, feature PM, Tim Sander. He wrote these very wonderful documents. Actually, when I was preparing my content, I had to go in to read every single one, and I was saying, wow, he really spent a lot of effort. He walked us with the journey, all the customer engagement, and how to bring the insight back, right? I think this set of documents are great for people to just kind of look into it and try to learn how to use the dedicated gateway, and also try to figure out if your workload can benefit from it. And I also want to do a little bit of shameless advertisement. That is a TV episode is coming on July 1st. My talk is more focused on behind the scene inspiration. I remember my first conversation, when I had a conversation with Tim about this episode. Tim told me people don't understand why we are exposing implementation detail, because people thought shared gateway and dedicated gateway is implementation detail. It's actually not implementation detail. Sure, they are different implementation. It is actually a different offerings that you could benefit from it. So it takes time to read through the document, analyze your workload, listen to Tim's talk, and see, if it's right for you. And we would love to hear from you. If you tried it, either go, excellent, let us know. No go, why no go, let us know, right? And we value both feedback. And the last one, that what I want to is just call out the kudos for the team. It is not just this set of people. It actually take the whole Cosmos DB to ship this. We kind of glance to gateway, glance to cache. The truth is portal. We provision from portal. You provision there, API coming in, right? And it's a huge, and billings, and many teams chime in to make this happen. But this set of people that I call out here are my architect. They foresee the architectural decision true. My PM team hold his hand true to make sure there is the right feature for customer. And my tech lead, Kavya, and quite many engineers to make that performance to where you can enjoy that offering. And the goal is, we believe a more integrated service can reduce more customer site of overhead. Customer like simple solution for them if the right solution, right? So that's kind of concluded my talk with you, Mark.
Tim's gonna. I know. Thanks for plugging Tim. So, folks, if you're Tim's gonna be on in a couple of weeks, and he's gonna take it kind of the last mile here on showing you. He's gonna do some demos, but he'll talk also about kind of the scenarios that make sense for why you would use this dedicated gateway and the integrated cache for Cosmos. So come and join us in a couple of weeks. He's got some really cool demos to show you with this, and also just share more information as well. So, well, Mei-Chin, I want to thank you very much for joining us this week here. It was great. It was just a great talk. I really like this. Maybe I should invite more of our engineering managers just to come on and maybe, I don't know, talk about what they do and how they do it. I don't know, maybe people will find that interesting, right? I mean, so far we just kind of talk about the features.
You cannot ask me, you had to ask our audience.
Yeah, right. So leave comments if you like these kinds of talks, folks, and or just hit me up on Twitter as well, and you can yell at me or make suggestions kindly as well on there. So great. Well, thank you, Mei-Chin.
Thank you so much.
Yeah, you're welcome. Thank you
for having me here. It's a pleasure.
So, folks, next week I've got PM Stephanie on our team. She's going to talk about a bunch of new monitoring stuff. So we've been doing a whole bunch of work in the monitoring space. We've got new monitoring integration, or new integration with the Azure Monitor stuff, workbooks support, all this great stuff. And so I'm going to have her on next week. She's going to show you all the latest and greatest for how you can monitor all of your workloads in Cosmos DB. So join us for that. So that's it. Thanks again, Mei-Chin. And I'm looking forward to seeing Tim's demos next week or 2 weeks from now. So,
me too. Yeah.
So,
Thank you, Mark.
Thank you. Bye-bye, everyone. Bye-bye.
Bye. Bye, everyone.